Hello, welcome back to the Security Conversations podcast. My guest is Abhishek Arya, Director of Engineering on Google's open source and supply chain security teams. Abhishek, welcome to the show. Let's start right there. What does the Director of Engineering on those two teams do?
Hello, Ryan. Thanks for having me. So I'm Abhishek. I lead Google's open source and supply chain security efforts. So this includes our work in the open to develop seamless security tools and solutions that work for the community. And we work hand in hand with the open source developers to get them adopted. We also do the work on hardening our own internal supply chains as well by leveraging these tools and principles that we learned externally.
Are there any projects or names of things we'd be familiar with? I imagine OSS-Fuzz is obviously the one that you've been more public with. When you mention open source and supply chain security teams, what are some of the internal projects there, the public projects that we know about that you're responsible for?
Yes. So as part of OpenSSF, so we were one of the early founding members of OpenSSF 3 years back. And we started to build this landscape of various open source tools and techniques we need to develop. So there are several projects under this arm. So things like we have the scorecards project, which is used to evaluate security risk assessment of your third-party dependencies. We have the SLSA framework, which is a set of principles on how you can have end-to-end integrity of your software supply chain. We have projects like OSS-Fuzz, which you are familiar with. This is focused on finding code vulnerabilities at scale. We have projects like OSV, which is focused on vulnerability management and fixing or patching known vulnerabilities in your dependencies. And we also are doing quite a bit of work in the upstream Linux kernel as well. So things like bringing Rust and Linux kernel is one, adding security mitigations like adding bounds checking and others.
I want to focus on OSS first because you guys have been in the news recently, sprinkling AI magic dust into OSS Fuzz and with some fascinating results. But I want to go back to the start. Can you take me back? I understand OSS Fuzz was created post Heartbleed, which was 2014, 9 years ago. After that, I think it was around 2016. Can you take me back there to that period and the decision to go in this direction?
Yes, so OSS-Fuzz is Google's free community service that helps find security vulnerabilities and functional bugs in critical open source projects using a massive compute cluster of 100,000 cores running on Google Cloud. So we created this back in December of 2016, as you said, in response to the Heartbleed attack and also stage fright attack, which were eye-openers to the industry in terms of the bigger impact they will have on the open source ecosystem. So if you think about Heartbleed attack, a regular fuzzer can find this Heartbleed bug in less than a few seconds. So this was a big eye-opener on how useful fuzzing is.
Right, but take me back to the status quo around that time. Fuzzing has been around forever. I remember writing about Microsoft adopting fuzzing into probably Vista back in the day. I remember going to Pwn to Own and watching Charlie Miller do his Pwn to Own exploits and talking about a lot of the work goes into the fuzzing, not necessarily writing the exploit on the back end. It's the hard work of doing the fuzzing. Let's go all the way back though. Can you, for those folks unfamiliar, can you explain what fuzzing is?
Yes, so I joined Google back in 2010, and those were early days in the fuzzing realm. Like I can tell you some of the work that Tavis Ormandy did in terms of bringing or doing media fuzzing by bringing in a large corpus of media files from the public web and throwing it on the media parser. So those were some of the early days. But when I joined,
and the idea is in the early days was you just throw inputs at a software program, throw random inputs as much as you can, but a lot of that was human mental manual effort to determine what those inputs would look like, and they slowly became better and better. But when you go back to those days, what was the status quo like? What did fuzzing look like then?
Yes, so fuzzing at that time was just throwing random inputs. It was not smart fuzzing. It wasn't guided by code coverage. There was a lot of work needed to even automate it. So back in 2010, one of the big drivers for this was we started Chrome rewards program. So I was one of the early members in the Chrome security team. And we started the Chrome rewards program in 2010, where people were submitting like garbled bug reports, like a long HTML file, which we would spend like half day or even a full day minimizing the test case to know where the bug is exactly. So I saw a huge opportunity in completely automating this by writing fuzzing engines which actually find these bugs, and also creating a full end-to-end fuzzing pipeline. Because finding the bug is one thing, we want to make sure that the bug is fully fixed. So we fully automated the pipeline in a way that a person only has to write, let's say, 20 lines of fuzzer code, and rest of the parts of the process, so things like the build glue, compiling the fuzzer, running the fuzzer at scale on hundreds of thousands of cores, and then how you find these crashes, how you deduplicate them is a fully automated process. That was a pretty interesting time, which is to actually develop fuzzing from more like a randomized testing method to a much smarter approach and making it anonymous, just like to unit testing. So if you think about unit testing, everybody is accustomed to it. So we try to develop fuzzing in a similar way by making it part of developer workflows.
What kinds of vulnerabilities we're talking about? Are there a specific kind of vulnerabilities that are detected through fuzzing? Is fuzzing better at finding this specific class? And are there patterns or common issues that maintainers should be aware of? And how are we streamlining getting this information to them? Can you talk a little bit about what fuzzing is useful for, and perhaps where there are limitations where fuzzing may not necessarily be the end all of finding bugs?
So we found quite a bit of success with fuzzing on memory unsafe languages. So like C, C++ are full of buffer overflow, use after free bugs. So places where we can find memory corruption bugs, fuzzing was extremely effective at. But over the years, we have actually seen the application of fuzzing towards other security problems as well. Things like how we are able to find information leaks, that can be done as well. We have also shown with Log4j how we can find remote code execution and information disclosure vulnerabilities. We have seen application of fuzzing in other areas of like functional testing too. So things like performance testing, or even differential testing, where you want to, let's say, compare two crypto implementations and you want to compare their outputs to see they are standardized. So there is quite a bit of efforts in fuzzing space.
The stats since the inception of OSS-Fuzz, pretty impressive. I think the last numbers I saw was 8,800 vulnerabilities detected, 28,000 bugs fixed overall. Can you talk a little bit about, at a high level, the impact that OSS-Fuzz has had on open source ecosystem as a whole?
Yes, the new numbers are even larger, I would say. The security vulnerabilities are more than 10,000 now. We are continuously fuzzing more than 1,100 critical open source projects, things like Kubernetes, TensorFlow, OpenSSL, and this is across a wide variety of languages. And the reason it has been so successful is because we have tied it to day-to-day developer workflow. So all the fuzzing runs on tip of tree trunk, where a developer is most accustomed to. And we actually provide fully precise information on where a vulnerability happened. So let's say if you write some new code today, in a few hours, you will get a bug file pointing to the actual mistake you did. So since this is very frequent in developers' mind on where this bug is, they would patch it quickly. So more than 70% of the bugs found by OSS-Fuzz are actually code regressions. And we have a more than 90% fix rate, which is kind of unheard in the industry considering how unsustainable open source ecosystem is. So being shift left and closer to the ecosystem or developer workflows helps here.
1,100 projects is still a tiny, tiny number, right? Like in the grand scheme of things, how do we get, can you talk a little bit about, are there criteria for open source projects to meet in order to be included in your testing? How do you expand that 1,100 projects to double that in a year or triple that in 2 years, right?
Yeah, so our criteria for bringing in projects is they should have an impact on the open source ecosystem. So this should be a critical open source project used by at least hundreds of open source consumers. So this can be from any big companies to governments to other critical open source projects too. So that has been the criteria, but we are looking at ways to fully automate it more. So we can bring many of these projects automatically. And some of our work with AI and LLMs is a great example of that, where we are now able to automatically write parts of the fuzzer targets as well.
Can you dig a little bit deeper into that? You just announced the addition of some LLM algorithms to expand code coverage in OSS-Fuzz. Can you go a little bit into the experiment, like the kind of processing power you need, what the experiment looked like? I think the blog post mentioned there was like a little bit of hit and misses here and there, took a lot of tweaking. Talk about the project if you don't mind.
Yes, so we have automated most parts of the fuzzing workflow, but the one part that still remains manual is the work has to be done by an open source developer towards finding the place where to start the fuzzing from. And this means the actual site which accepts untrusted user input. This can be a hit and miss too, because a fuzzer might cover some part of the code base and might not cover other critical parts. So we have leveraged AI and LLMs towards finding those other code areas that should be covered by this fuzzer unit test in a fully automated way. And this works very well because the LLMs actually understand these code structures and relationships pretty well. Like, they have been trained on large amount of code bases. So they actually understand these relationships. So when we, let's say, tell for a fuzzing project, like, let's say, tiny XML2, it can tell, like, hey, this is a particular function or API that is missing in your unit test. And if you add this, it works pretty well.
So like
And
a Copilot component.
yes, think of like a Copilot component, but it's even smarter in terms of it can suggest new code. But then if there is, let's say, a compile error that happens from that code suggestion, it can help to suggest the fix for that as well. So end to end, we are able to automate full part of the pipeline.
And that is today outside of the realm of humans, or is it just takes it just like what does AI replace there, or what does AI shine a light and
So the fuzzer authors don't have to write any of that new code to cover the uncovered part of the code base. So think of many of the bugs that fuzzing miss today are actually uncovered code by the fuzzer. And the
right?
same applies for unit tests too. Like, your unit tests might cover 40 to 50% of the code base, but if you have something that is not covered, you might miss catching the stability bugs or regressions there. So it's super important to have the fuzzer cover all parts of the code base.
What has been some of the early results? Have you been able to quantify the difference between the fuzzer with LLM versus prior to, and what can you share some of those results?
Yes, so we have seen pretty promising results on around 30 to 50 projects that we have evaluated so far. We have seen even coverage bumps of up to 30% in a fully automated way. And this research, we want to do it in collaboration with the open source community. So that's why we shared all the detailed prompts we used to pass to LLMs and how we developed this overall process. Because ultimately, this is a research we want to do with the community. That's how we have been so successful with OSS-Fuzz and the fuzzer benchmarking service too. We released it everything out to the open, so that's how we have been being able to iterate it with the fuzzing research community.
Is there a fear? Because to me, this feels like this is a race for the folks who have the most resources and the ability to do this. You have to imagine if defenders like you are doing this, you have to imagine well-resourced nation-state actors who are very interested in these very critical open source dependencies and components and vulnerabilities there are already doing the same thing, throwing LLM algorithms at them. Is this just a race to see who can do it faster? Where do you see this going as it relates to offensive guys doing the same thing?
Yes, so it's definitely a race, but I would say AI and LLMs are helping the defenders more,
How?
because in a way, the scale of work that has to be done, that is much easier with AI and LLMs. Like, think about open source is a very unsustainable ecosystem. We don't have so many security teams and solutions to actually get widely adopted in the open source ecosystem. So AI and LLMs, we are seeing quite a bit of applications that we can apply across different areas. Like, we are researching it to different techniques, how we don't have to do many of these tasks manually. And I can give you some examples of that as well.
Yeah, if you don't mind, I'm fascinated by AI use cases in security that goes beyond chatbots that actually are, leapfrog things. And and I know there's a bunch of experiments happening everywhere about the stuff that you can talk about. Can you talk about what excites you about AI beyond vendor hype and all this like
Yeah.
nonsense about changing the world? But things that truly excite you that AI applies very, very perfectly. What are some of those areas that
Yes, so one of the other areas that we are looking at is automated remediation. So things like, for an open source project, there are so many known vulnerabilities that exist. So things like known vulnerabilities in your dependencies. So we can use AI and LLMs to, let's say, upgrade those dependencies and also fix some of the functional API mismatches and failures that usually a manual tester would have to go in and actually do that, because that's what precludes some of those innovations right now. Is there is quite a bit of manual work required to keep your dependencies up to date. So there is quite a bit of potential if we can completely automate the remediation of known vulnerabilities. So that's one area that comes to mind.
It just feels like anything that has an overly manual task that
Yeah.
slows you down because of this manual nature. AI just generally fits there very well. Speeding up tasks, we mentioned Copilot. What are some other, in addition to vulnerability research, bug finding, vulnerability fixes, any other ones come to mind?
Yes, so there could be other applications too. So there is another area we are looking at, which is how can we determine suspicious commits in an open source repo? So one of the big examples here is many of the open source projects are actually maintained by single maintainers. So they can give these projects to a malicious party tomorrow for a bag of money.
Or that could
How
be a
can
malicious maintainer himself or herself, right?
malicious maintainer themselves too?
Playing the
So
long game. I mean, you have to imagine nation states must be doing that, playing this long game. So that's a legitimate security risk there.
exactly. So there is a lot of potential of LLMs and AI to actually find those anonymous patterns in commits. Like, does the code actually connect with the description that the developer provided? What is the malicious? Is there any malicious code in that commit? So there is quite a bit of applications there. So we are exploring at the moment.
And you think that's like that's potentially game changing, because I feel like that's an area that's so blind to us, that malicious maintainer passing it
Yeah.
or himself using it, playing that long game, and the reality that nation states must have been doing there. You really think that we can potentially make that dent there with AI?
Yes, definitely. Like if you remember how we had those PHP commit exploit like a year back, where on a Sunday there were two commits that happened on a PHP repo. That was a pretty easy case to detect via AI and LLM. So there is quite a bit of potential to automatically detect these.
No, I wanted to switch gears to software supply supply chain security, which is a whole other area, a whole ball of wax filled with complexity and technical debt and policymakers trying to figure things out. I don't want to throw you too much. I don't want to get too in the weeds with it, but as you, from your perch at Google, managing supply chain security there, can you talk a little bit about where we are today, where we stand, and the long road ahead?
Yes, so I would say we have made huge progress in the last 3 years since the SolarWinds attack happened and also the executive order came out. So, as part of the OpenSSF member community, we developed all these great projects which cover different parts of the supply chain problem. So, I don't know if you've looked at the SLSA threats diagram, there are at least 8 attack points that can happen across your different parts of the software development lifecycle. So, we had to actually develop solutions that work well for those. So, things like SolarWinds attack happens when your build infrastructure gets compromised, or code curve attack, which just requires someone to steal just the bearer credentials to storing your package artifact. So there are different problems that we have to solve, and we have created some great solutions. I think some of the challenges that lie ahead is more about getting those tools and solutions adopted seamlessly in the software development lifecycle for these projects. And we even created actually a dedicated subs team which works hand in hand with the developers to get those adopted, because I think adoption is a much bigger goal now, provided we have the solutions in the space now.
What slows down that adoption, though? What is the friction point in getting that adoption smooth?
So first thing is it has to not put additional burden on the open source developer. So that is the primary key to this thing. So one of the challenges is sometimes they also don't understand how these security solutions work. So when we talk to them, we first introduce them on what value it brings. Education is one of the biggest thing we focus on before we even start the conversation. So we don't put, let's say, a direct pull request. We actually first create an issue in the issue tracker, talking about who we are, how we work with OpenSSF, what is the value of these tools and technologies in bringing them. So education is a critical aspect, and then actually making sure we listen to the feedback to improve these tools and solutions, so they are much more seamless to integrate.
And you mentioned OpenSSF. They have this Alpha Omega project. I had Omkar on the podcast just recently talking a little bit about that stuff. You guys are a big partner with OpenSSF there. I want to ask a question here. What would you say identify as the biggest challenges in software supply chain security? And are you on board with that approach, this Alpha Omega approach of pinpointing areas and identifying areas, so it's really not just passion projects, and
Yeah.
then like throwing tools at it?
Yes, so we are super excited about the Alpha Omega project. In fact, we are the one of the three big partners who funded the Alpha Omega pool along with Microsoft and Amazon. The way Alpha Omega has been super successful is it's trying to fund various security foundations towards adopting these security tools and technologies. So think about the Python Software Foundation now has a dedicated security developer in residence, which is triages bug reports, adds these security tools and techniques to the Python infrastructure. And similarly, we funded different foundations like Node.js and others, or Eclipse Foundation. So it's making huge progress in terms of the first baby step of actually making a difference towards the basic security hygiene first.
So you're a big fan of what's happening there.
Yes, we are a big contributor there too.
And just to circle back on the AI conversation, we just saw DARPA and this AI Cyber Challenge putting up some prizes around building challenges and going to DEF CON and really engaging with the security research hacker community around AI use cases there. Is that something that excites you, and what are some of the promise of things like that?
Yes, we are definitely a contributor there and super excited about the initiative. The reason that it brings a lot of value is it encourages research in the community towards using these large language models and looking at these automated security applications. So things like I mentioned to you, the automated remediation and others. We want community to come up with these use cases where they can actually leverage AI at scale to solve these problems, like make the defender's life much easier, because the scale of problems is much larger. We cannot solve these with just the manual developer task of improving security.
I'm sorry to be bouncing around, but I wanted to just make sure I touch all these points. Going back to software supply chain, are there areas in the industry that you think the industry, government, whoever might be overemphasizing and over pivoting? Are we?
I would say we are definitely over pivoting on some areas. So things like there is the SBOMs area, which people think as the panacea for all, which is not really the case. Like I'm definitely a big fan of software transparency. So SBOM is definitely helping towards that. But the industry needs to understand on how to get SBOMs right. Like SBOMs on its own can be incomplete, incorrect, and not trustworthy. Like I just hand you over a SBOM, you might not say like it has all the dependencies in it and whether it was generated the right way. So we as an industry needs to understand how to have trustworthy SBOMs, and this is where SLSA comes in too, which is we need to capture SLSA provenance as part of the software build process, so we know what is coming out is actually reliable and then use those to generate SBOMs. And that's
Right.
also one part of the picture, I would say.
SBOMs is dominating the headlines, though, right? And I mean, that's the fear. The fear is that we're over pivoting and over emphasizing one area where it might not get the best ROI. What are the areas that gets potentially the best ROI that we should be fixated on today if it's not SBOMs?
Yes. So SLSA is definitely one important area, which is we want to protect against attacks like solar winds and code curve by hardening the build pipeline, having full maturity in the software development process, so we can make sure none of the parts in the STLC are tampered with. So that's one area that is very close to me, which is making sure every organization improves their SLSA compliance story. That's one. There are several other important areas too. So right now, most of the enterprises on the planet, when they bring in third-party dependencies, they don't do a risk posture evaluation. This is super important. And this was a problem that happened for Google too. We try to fix it, which is having that security posture evaluation is super important.
What is that? Can you linger there for a second? What is a risk posture evaluation? Is that an internal pen test type thing?
So previously, the most of the people always thought about code vulnerabilities as a security posture, but we want to think about beyond that. Like, what are the security best practices that open source project use? So SLSA is one example. Other examples they use, does it use basic security hygiene? So things like, does it do code reviews? Does it do software signing? Does it do continuous testing as part of its SDLC? So this is where the scorecards project comes in very handy. And it is a set of checks that helps to guarantee that this project follows all the security best practices.
I want to pick your brain. What do you view as the most promising commercial opportunities within software supply chain realm?
I mean, there are definitely various areas. One of the very promising area that I've seen Google Cloud use too is creating that end-to-end offering. Like we have the software delivery shield, which focuses much more around making sure we have full end-to-end integrity in your supply chain. Things like from hardening your source code where it's placed to hardening the builders to hardening the artifact storage system where your artifacts are stored, to have a full policy infrastructure around ingestion of your dependencies. So I think there is a lot of commercial opportunities there, but there are other areas which are pretty important too. So things like vulnerability management as well. Like right now, if you remember the Equifax attack, which impacted 150 million Americans, it was just a Apache Struts dependency, which is like a 2-month-old dependency. How can we automate the patching of software with respect to the third-party dependencies we ingest is super important.
So you see there's like green field there for innovation around getting those things right.
Exactly.
What's your take on how global governments have begun regulating software supply chain topics? It's not just here in the US with executive orders and national cybersecurity strategies, but in Europe, it's very, very tense times around the way they're viewing it. Do you have a take on where this is all heading and how developers and companies should be prepping for it?
Yes, so these regulations are definitely a positive development for the industry, but we have to make sure that these regulations are designed right. So an example is the Cyber Security Resilience Act, CRA, which tries to put the liability onus on an open source developer and fining them for non-compliance. I think these kind of things cannot work because an open source developer, when they create that open source project, it intentionally comes without any guarantees. Like open, that's the theme of open source software. So I think we need to really design those regulations right to actually fit in with the needs of the ecosystem.
Be more realistic, right? I heard
Yeah,
someone mention that specific passing the liability onto the developer is essentially a ban on open source software
yeah,
because like who's going to be able
exactly,
to, who's going to want to absorb that, right? I mean, how
exactly.
do we how do we bridge these conversations where the policymakers are talking a different language from what the guys on the ground talk? Like how do we get there?
Yes, and it will curb innovation in open source in Europe, I
You
would say.
think so?
Yes.
There's growing conversation about shifts in software liability as well. You have a perspective on how companies can best prepare for these potential changes?
I think this is yet another positive development where it's important for these companies to realize that there needs to be basic security hygiene as part of their products. Like I think we as an industry have to step up the game in terms of when we are consuming open source software, we need to take responsibility for it and contribute back. Like I can tell you for Google, it is a great example where we have built a team which develops security tools for the community. We also focus on getting those tools adopted. And then we also fund the community towards actually adopting these things, so like giving it to foundations, research, and vendors. So I think every open source consumer need to step up there.
Yeah, but why do we have to fight with vendors to ship something that's secure by default, secure by design? I mean, this is a CISA initiative now that is taking on root, coming out of the National Cybersecurity Strategy, where CISA is saying, listen, things have to have these basic foundational things in place. And this is something we have to fight for. If it's so logical and natural, like why do we have to scramble to get vendors to just, stick to these basic foundational things? Like, why are we in this place?
I would say like this is a important responsibility because if we are shipping a critical product that is used by tens of thousands of consumers, like think of just CodeCov, which is a code coverage library that was used by 30,000 persons around the world. If somebody is shipping that library, it's super important to protect it end to end because otherwise we will have ramifications of hundreds of millions or billions of dollars in damages. It's a massive impact.
We've established that there's a lot of white noise and there's a lot of over pivoting and folks going in perhaps the wrong directions. I want to close out with one last question for you. In terms of software supply chain security efforts, how can organizations best measure initiatives? Because this measurement piece is becoming a really, really difficult thing for CISOs and security defenders everywhere. But just measure these initiatives to ensure they're, the right set of resources are going towards the right set of things in software supply chain, and we're not chasing, putting 50% of my team on SBOMs when the value there is minimal. Like, can you talk a little bit about some ideas around measurements and some ideas around resource allocation?
Yes, so I'm pretty fascinated by this concept called like a risk trend line. So what this really means is every organization should first start thinking about knowing their denominator, or first having a full transparency or observability of all their assets that they have in the organization. So that's kind of like step one. And then starting to measure the
It's not a
risk.
trivial task, though, right? Like that in itself is like an impossible task, right? This like asset management, asset discovery, asset.
Yes, so there will always be a long tail, but at least we should have basic measures where, let's say, we are not pulling in a random dependency as part of your build process. Like we should have hermetic builds. So in a way, that's where SBOM was very useful, right? If we have an organization which produces SBOMs for all their build processes, that would be a huge win, because then you can actually see a full dependency posture of both your first party code and the third party dependencies you have. So starting there is super important. And then having a goal of, let's say, 6 to 12 months on how can we bring that risk timeline down? Like, are we decreasing our risk? What are the security improvements we are doing? So that's one idea I have. The other one is around vulnerability management. I think this is a pretty common theme where you should be looking at, are you able to meet your vulnerability SLOs for both your internal and external bug reports? Do you have a plan on incident management? So let's say Log4j hits you tomorrow. Are you really tracking your dependencies in Google Docs, or you actually have a real system which can tell you where those things need to be patched ASAP? So having that kind of a plan is super important.
Do you feel like we're getting it, that things are generally getting better? Or is there like a day as you get into the office, you sit at your desk and you take a deep sigh that I can't believe we're still here? Give the audience a sense of, are you this optimist that we're generally going in the right direction? And you and I having this podcast 5 years from now, these are all problems in the past?
I'm pretty optimistic of the progress we have made in the open source ecosystem. I can give you an example of OSV schema, which is now adopted by 20 ecosystems. So basically, every language ecosystem is exporting their vulnerabilities in the most precise fashion. We are seeing huge adoption of open source projects running scorecards project as part of their regular risk assessment posture. We are seeing great finds from OSS-Fuzz. So there is definitely progress, but yeah, we still have a long way to go. So
Thank you very much, Abhishek. Appreciate the time. Thank you for coming and sharing your expertise and some of your experiences with the audience. Thank you very much.